Hello guys, what's up? This is Sir EJ and welcome again to another math tutorial. In today's topic, we will be discussing how to solve problems involving probability of union and intersection of two events. These are the following objectives we need to attain in today's topic. At the end of the lesson, the students should be able to: letter A, find the probability of union and intersection of two events. Letter B, solve problems involving the probability of union and intersection of events. And letter C, appreciate the relationship of union and intersection of events in real-life situation. These are the formula that we will use if we will solve for the probability of union and intersection of events. First one is we will use the formula of simple probability. Probability of E is equal to the number of event outcomes all over the total number of possible outcomes in the sample space. And for the formula of union of two events, we will be using probability of A union B is equal to the probability of A plus probability of B minus the probability of A intersection B. Let's have our first problem. A box contains 5 white balls, 6 red balls, and 4 blue balls. What is the probability of drawing a white ball or a red ball? Let's identify first the given. Event A, which is getting a white ball, is equal to 5 because there are 5 white balls. Event B, which is getting a red ball, is equal to 6 because there are 6 red balls. And event C, which is getting a blue ball, is equal to 4 because there are 4 blue balls. After that, we will be identifying the total number of sample space, which is we can solve it by adding the 3 events. So we have 5 white balls, 6 red balls, and 4 blue balls. So adding these numbers, we will get 15. So this is the total number of sample space. After that, we will be identifying if this is an example of union or intersection of events. Obviously, this is an example of probability of union of events because there is a word "or" in between the white ball and the red ball. So we will be using the probability of union of two events. Probability of A union B is equal to the probability of A plus probability of B minus probability of A intersection B. Probability of A union B is equal to the probability of A, so we have 5 event outcomes all over 15 total number of sample space, plus the probability of B, which is equal to 6 event B all over the total number of sample space, which is equal to 15. Minus the probability of A intersection B, which is equal to 0 over 15 because there is no intersection between the white ball and the red ball. So 0 event outcomes all over the total number of sample space, which is equal to 15. And then we will be simplifying this one. Since this is an example of similar fraction, we will just copy the denominator 15 and then add the numerator. 5 plus 6 will be equal to 11. Therefore, the probability of getting a white ball or getting a red ball is equal to 11 over 15. Let's have our second example. A cube with letters A, B, C, D, E, and F on its faces is rolled. What is the probability of rolling a vowel or a letter in the word prod? Let's identify first the given. So event outcomes of A, which is rolling a vowel, is equal to the letters A and E, because these are the vowels that can be found from the letters A, B, C, D, E, and F. And that is equal to 2. After that, event outcomes for event B, rolling a letter in the word prod, is equal to the letters A, D, and F. Letter A is found on the word prod. Same goes with letter D and letter F. So these are the three letters. So we have event B, which is equal to 3. And then for event A intersection B, what are the letters that occurred in both events? We have the letter A. So we have A here for event A, and then another A here for event B. So A occurred on both events. So therefore, the intersection of A and B is the letter A. So it is equal to 1. And then after that, let's identify the total number of sample space. So the total number of sample space is equal to 6 because there are 6 letters on a cube. And then we will be identifying if this is an example of union or intersection of events. And obviously, this is an example of union of two events because there is a word or in between rolling a vowel and a letter in the word front. We will be using the formula for union of two events. Probability of A union B is equal to the probability of A plus probability of B minus probability of A intersection B. After that, we will bring down the probability of A union B equals the probability of A. So event outcomes of A rolling a vowel is equal to 2 all over the total number of sample space is equal to 6 plus the probability of B, so event outcomes of B is equal to 3 all over the total number of sample space is equal to 6 minus the probability of A intersection B, so event outcomes of A intersection B is equal to 1, and then the total number of sample space is equal to 6. Since this is an example of similar fraction, we will just copy the denominator and then add the numerator. So we have 2 plus 3 is 5 minus 1 is equal to 4. 4 over 6 lowest term is equal to 2/3. Therefore, the probability of rolling a vowel or a letter in the word prod is equal to 2/3. Let's have our next example. RJ likes to wear colored shirts. She has 20 shirts in the closet. 8 of these are blue, 6 are red, and the rest are in different colors. What is the probability that she will wear a blue or a red shirt? Let's identify first the given. So event outcomes of A, which is getting a blue shirt, is equal to 8. Event outcomes of B, which is getting a red shirt, is equal to 6. And then after that, event outcomes of C, which is different colors of shirt, is equal to 20, the total number of shirts, minus the quantity of the sum of the blue shirts and the red shirts. So we have 8 plus 6. 8 plus 6 is equal to 14, then 20 minus 14 will be equal to 6. So therefore, event outcomes of C, which is getting a different colors of shirts, is equal to 6. And then the total number of sample space is equal to 20, which is already given. We will be identifying if this is an example of union or intersection of two events. So there is a word or in between the blue shirt and the red shirt. Therefore, this is an example of union of two events. We will be using the formula of probability of A union B is equal to the probability of A plus probability of B minus probability of A intersection B. And for the probability of A, we have event outcomes of A, which is equal to 8, all over the total number of sample space, which is equal to 20, plus the probability of B, so event outcomes of B getting a red shirt is equal to 6, all over the total number of sample space, which is equal to 20, minus the probability of A intersection B, so the total number of sample space is equal to 20, and A intersection B, the intersection of A and B is equal to 0, because she cannot wear a blue shirt and a red shirt at the same time. So this is equal to 0. And then we will be simplifying this one. Similar fractions, copy the denominator, and then add and subtract the numerator. So 8 plus 6 is equal to 14 minus 0, 14. So we have 14 over 20, and lowest term is equal to 7 over 10. Therefore, the probability that she will wear a blue or a red shirt is equal to 7 over 10. Let's have another example. Out of 5,200 households surveyed, 2,107 had a dog, 807 had a cat, and 303 had both a dog and a cat. What is the probability that a randomly selected household has a dog or a cat? Let's identify first the given. So we have event outcomes of A, the household with a dog, is equal to 2,107. And then we have event outcomes of B, the household which has a cat, is equal to 807. And then the intersection of A and B, the household with a dog and a cat, is equal to 303. And then the total number of sample space is already given in the problem, which is equal to 5,200. We will be identifying if this one is union or intersection of events. And since there is a word or in between dog and cat, so this is an example of union of two events. So we have probability of A union B is equal to the probability of A plus probability of B minus probability of A intersection B. And then after that, bring down probability of A union B equals probability of A. So we have event outcomes of event A, which is equal to 2,107, all over the total number of sample space, which is equal to 5,200, plus the probability of B, event outcomes of B is equal to 807, all over the total number of sample space, which is equal to 5,200, minus the probability of A intersection B is equal to the event outcomes of A intersection B, the household with both dog and cat, which is equal to 303, all over the total number of sample space is equal to 5,200. And since this is an example of similar fraction, just copy the denominator and then add and subtract the numerator. 2,107 plus 807 minus 303 is equal to 2,611. Therefore, the probability of randomly selecting a household which has a dog or a cat is equal to 2,611 over 5,200. Let's have our last example. A die is rolled. What is the probability of getting an even number or a factor of 2? Let's identify the given. Event outcomes of A, which is rolling an even numbers, are the numbers 2, 4, and 6. So the event outcomes of A is equal to 3. And then event outcomes of B, which is rolling a number which is a factor of 2. What are the factors of 2? So that is also 2, 4, and 6, which is also equal to 3. And then event A intersection B, so these are the numbers that occurred on both events, event A and event B. So we have 2, 4, and 6. So all these numbers occurred on both events. So event A intersection B is also equal to 3. And then the total number of sample space. So a die is rolled, so there are 6 numbers in a die. So that is equal to 6. And then after that, we'll be using the formula. Probability of A union B is equal to the probability of event A plus probability of event B minus probability of A intersection B. So we have probability of A union B equals probability of A, event outcomes of A is equal to 3, all over the total number of sample space is equal to 6, plus the probability of B is equal to 3. And then the total number of sample space is equal to 6, minus the probability of A intersection B. So A intersection B is equal to 3, all over the total number of sample space is equal to 6. And then we will simplify, copy the denominator since this is a similar fraction. 3 plus 3 is equal to 6, and then 6 minus 3 is equal to 3. Lowest term of 3 over 6 is equal to 1/2. Therefore, the probability of rolling a die and getting an even number or a factor of 2 is equal to 1/2.